Hello everyone, this is Chinnaiah Kalpana here. In this video, we're going to see a problem from partial differential equation. So let's get going. Problem: form partial differential equation by eliminating phi from x, y, z equal to phi of x square plus y square minus z square. So we are asked to form a partial differential equation by eliminating this phi, an arbitrary function, from this equation or a relation. Given x, y, z equal to phi of x square plus y square minus z square, consider as equation number 1. Now let's partially differentiate it with respect to x. Partially differentiating 1 with respect to x, right? Just apply dou by dou x on both sides of 1. Since we are partially differentiating with respect to x, so we'll treat y as constant here. This gives us, here y is constant, right? So we'll write this term as y into partial derivative of uv equal to partial derivative of phi of x square plus y square minus z square with respect to x is phi dash of x square plus y square minus z square into inner derivative, that is dou by dou x of x square plus y square minus z square. This gives us y into, here you're having x into z, right? We need to find the derivative of xz. So we'll apply uv whole dash formula, which is u dash v plus v dash u. This gives us dou by dou x of x into the z plus dou by dou x of z into x equal to phi dash of x square plus y square minus z square into partial derivative of x square plus partial derivative of y square minus partial derivative of z square, which gives us y into partial derivative of x with respect to x is 1 into z minus partial derivative of z with respect to x is dou z by dou x into this x equal to phi dash of x square plus y square minus z square into partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0 minus partial derivative of z square with respect to x is 2z into dou z by dou x. Since we have a notation dou z by dou x equal to p, let's replace dou z by dou x by p, okay, which gives us y into 1 into zz minus, replace it by p, you'll get p into x, px equal to phi dash of x square plus y square minus z square into 2x minus 2z into p. Now take 2 common from these two terms, you'll get y times z minus px equal to phi dash of x square plus y square minus z square into 2 times x minus zp. Okay, consider it as some equation number 2. Now let's partially differentiate 1 with respect to y. Partially differentiating 1 with respect to y. Just apply dou by dou y on both sides of 1. Since we are partially differentiating with respect to y, so we'll treat x as constant here. This gives us, here x is constant, right? So we'll write it as x into partial derivative of uv. Again we are going to apply uv whole dash formula. Uv whole dash equal to u dash v plus v dash u, right? Equal to partial derivative of phi of x square plus y square minus z square with respect to y is phi dash of x square plus y square minus z square into inner derivative, that is dou y of x square plus y square minus z square. This gives us x into partial derivative of y into z plus partial derivative of z into y equal to phi dash of x square plus y square minus z square into partial derivative of first term plus partial derivative of second term minus partial derivative of third term. This gives us x times partial derivative of x with respect to x is 1 into z plus partial derivative of z with respect to y is dou z by dou y into y equal to phi dash of x square plus y square plus, sorry it's minus, right, minus z square into partial derivative of a constant with respect to y is 0 plus partial derivative of y square with respect to y is 2y minus partial derivative of z square with respect to y is 2z into dou z by dou y, right? Since we have a notation dou z by dou y equal to q, right? Now let's replace dou z by dou y equal to q. We'll replace dou z by dou y by q, which gives us x into x times 1 into z plus, replace it by q, we'll have qy equal to phi dash of x square plus y square minus z square into 2y minus 2z q, right? Now take 2 common from these two terms. You will get x times z plus qy equal to phi dash of x square plus y square minus z square into 2 times y minus zq, right? Fine. See, here we'll have plus, not minus, it's plus, okay? Now observe equation 2 and 3. In both the equations we have phi dash of x square plus y square minus z square. Let's eliminate phi dash of x square plus y square minus z square from both the equations using 2 by 3. LHS of 2 by LHS of 3 equal to RHS of 2 by RHS of 3. Can cancel phi dash of x square plus y square minus z square and 2, and this gives us equal to x minus zp by y minus zq. Now we need to simplify it. yz plus pxy by xz plus qxy equal to x minus zp by y minus zq. Make a cross multiplication. We'll get yz plus pxy into y minus zq equal to xz plus qxy into x minus zp, which gives us yz into y square z, yz into zq minus z square yq or qyz square. Okay, you can write this term as qyz square. Qyz square, better. Pxy into y, pxy square, plus into minus minus, qxy into zq is pqxyz equal to xz into x square z minus xz into zp, x, okay, p x square z, right, xz into zp, right, z square, we'll get pxz square, pxz into z square. Fine. Now qx into x plus qx square y plus into minus minus qxy minus zp gives minus pqxyz, right. See, this term exists in LHS and RHS, so let's cancel it. And now write the terms involving P and Q in LHS and the terms which does not involve P and Q in RHS. Okay, I'll take this to RHS and we'll bring these two to LHS. So I'll bring this first. Px, here you're having minus, right, becomes plus. Here it's plus, so we'll get minus here, q x square y. Now write these two terms as it is, minus qyz square plus pxy square. You have this term, right, which does not involve p and q. Write this as it is in the RHS and bring this, take this to RHS, we'll get minus y square z. You can take z common from these two terms. Fine. Now take qy common from these two terms and px common from these two terms. Okay, let's see. Or you can take z square common from these two terms and xy common from these two terms. Okay, you have options. Fine, let me write one more step. We'll show you in both the ways. Okay, fine. Now I'll write the terms involving px first. Pxz square plus pxy square. Now write the terms involving q. Take z common from the two terms of RHS. Okay, now you can take px common. See, px exists in both the terms, right? So let's take px common. We'll get px times z square plus y square, or you can write it as y square plus z square. And here qy is common in both the terms, right? And also minus. Take qy common, you'll get qy times x square plus z square equal to x square minus y square into z, or we can write this as p into, we can write z square plus y square as y square plus z square into this x minus q into x square plus z square into y equal to x square minus y square into z, which is the required partial differential equation. Or let's think another way. Observe all the four terms. See, I'm writing the same step here, okay? Fine. So I'll write the terms involving z square first. Pxz square minus qyz square. Now I'll write the terms involving, it involves xy, right? Let it be. I think I have covered all the terms. 1, 2, 3, 4. Fine. Take z common from the two terms of RHS. Now let's take z square common here. We'll get z square times px minus qy. And here let's take xy common. Let's take minus xy, better. Minus xy times q into, we'll have 1x here. Minus, since you took minus common, right? Minus and minus gives plus. Here you're having plus, so we'll write minus here. Fine. If you take xy common, you'll get p into 1y. You can get this or this. Okay, fine. Z square of px minus qy plus, yeah, you can also write this term as, if you want to write py term first, you can just take minus common from these two terms. You can write like this also, there's nothing wrong in it. Minus into minus plus, xy into py minus qx equal to x square minus y square into z. You can get any of these three or anything else. Okay, it's up to you. Fine, we have solved the problem. Well, we have seen a problem from partial differential equations in this video. I hope you'll understand. We'll see you in the next video. Until then, bye bye.